Hey all, so listen to this. Pythagoras asked the one big question but emerged with a very different answer. So he was a vegetarian who believed in reincarnation and declared that eating beans was sinful. He and his disciples worshipped numbers and thought that the world was made of them, a truth most obviously revealed by ratios, squares, and right-angled triangles. He declared that justice was the number 4 because it was like a square number, because it was a square number. He was finally shocked by his discovery that irrational numbers like pi and the square root of 2. He even drowned one of his students, Hipparchus of Tarentum, for revealing this awkward truth to outsiders. Okay, so he was an interesting cat. Vegetarian, nothing against vegetarian, but yeah, something against killing your students. I would never do that, just so you guys know. So, that aside, let's dedicate this problem to Pythagoras. Alright, so the problem we're looking at here, we got a 50-foot supporting wire to be attached to a 75-foot antenna. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 20 feet from the base of the antenna. How high from the base of the antenna is the wire attached? Then we've got another question. Local regulations require that supporting wire need to be attached at a height no less than 3/5 of the total height of the antenna, so have local regulations been met? Okay, so let me switch my screen a little bit here. Maybe. There we go. It's kind of small, I apologize. I wanted to be able to show you guys the actual word problem too. So here's a diagram that I've drawn. So we've got this wire attached at some distance x. We don't know that distance of the pole of this 75-foot pole here, and anchored at a distance 20 feet from the end of the pole there. So Pythagorean theorem, you guys know this, a squared plus b squared equals c squared. So a and b are interchangeable as long as the side opposite the right angle, or the hypotenuse here, is going to be c, right? So I'll let a be 20 and x can be my b, which means we're solving for my b. So let's solve this a squared plus b squared equals c squared for b. So we'll subtract the a squared over, so we're looking at b squared equals c squared minus a squared. And then we'll square root both sides, so we're looking at the square root of c squared minus a squared. Okay, that's a formula derivation where we're going to use. Bear in mind, this is not the same thing as b equals c minus a, okay? I cannot just square root these guys with a square root symbol. My minus sign, my subtraction sign right there will not let me do that. So plugging things in, x, that's what I'm after, equals the square root of c squared, which is going to be 50 squared, minus a squared, so that's 20 squared. So that's the same thing as the square root of 2500 minus 400. So that's going to be the square root of 2100, which is going to be about 45.8 feet. So looking back to the question, let's see, what was it? A height no less than 3/5 of the total height of the antenna. So we need to look at 3/5 of the total height. Let me switch colors to illustrate this point. So 3/5 of my total height, that's 3/5 of 75, right? Well, 3/5 of 75, when you multiply that out, it's going to be 45 feet. So what we're saying here is this wire needs to be higher than 45 feet off the ground. And it is. It's 45.8 feet off the ground. So I'm barely meeting regulations, but I am meeting regulations of being in excess of that 45 feet. So this is a good real world type of problem that engineers would do something like this. Of course, probably a little more difficult, more advanced than this, but this gives you an idea about the sort of thing you would use in a regular situation in the real world.